Hey guys, today we're going to talk about chemical equations. And first, we're going to talk about what is a chemical equation, and we're going to look at the different parts and understand what it means and how to put it together, a chemical equation. And then after that, we are going to learn how to balance a chemical equation. And you'll understand what that means when we talk about how to do it here. And that will help us learn how to balance a chemical equation. So let's talk about that. Okay, so a chemical equation looks something like this. Okay, you can see in the equation there, you can see the symbols, the formulas for four different chemicals. Okay, at the beginning you can see CH4. CH4 is a chemical called ammonia. And then following that, you can see O2, which is oxygen. And then there's an arrow. We'll talk about that arrow in a second. And then you can see CO2. CO2 is called carbon dioxide. And finally, the fourth one on there, H2O, as you're probably aware, is water. So there's four chemicals there in that particular chemical equation. Chemical equation doesn't have to have four, right? At least two, but it can have, many chemicals in it, or it can have, just two, maybe, at least, right? Okay, there are, if you look at that chemical equation, a few different symbols in there. Okay, you can see an arrow in the middle of that chemical equation, and that arrow represents the action happening in a chemical reaction. Okay, the chemicals that are before the arrow are what are called the reactants. They're the chemicals that we started with. Okay, and then the arrow represents the action happening, and then the chemicals on the right side of the equation are what are called the products. They're the chemicals that are produced during the chemical reaction. So if I were to look at this particular chemical reaction here, I would say that this says that ammonia and oxygen, I'm going to look at that arrow and I'm going to say they react to form, or they react to produce, something like that. So ammonia and oxygen react to produce carbon dioxide and water. And that is a chemical equation that tells us what happens during the reaction. Okay, now let us talk about some different parts of a chemical equation that I did not show in this particular one. Okay, 1 second and we will talk about some different parts. Okay, now I'm going to put up the same chemical equation that you just saw, but I'm going to put in a few more symbols. Okay, the first one we looked at there was very simple. Chemical equations usually have a few more symbols in them, and I'm going to talk to you right now and tell you about what they mean. Okay, so the one that you can see up there now, it has the same four chemicals. It's still got ammonia and oxygen reacting to form carbon dioxide and water, but now you'll see in there some things that are in blue and some things that are in red that I've added. Okay, let me talk about the blue things first. For each chemical in your chemical equation, you can put a letter in parentheses after that chemical to tell you whether it was a solid, a liquid, a gas, or it was dissolved in water. So you can see the symbol after the ammonia, CH4. You can see a parentheses with the G inside. Well, what do you think the G stands for? Solid, liquid, gas, or dissolved in water? Gas, obviously, right? So three of them there have a G. They're gases. And you can see the water at the end has an L, which tells you it's a liquid, right? If you had one there that was dissolved in water, we call that aqueous. And so the symbol that you would see in there would be a AQ. So you'll either see S, L, G, or AQ for dissolved in water. And that's a very common one, AQ, aqueous. You'll see that quite often. Okay, now those are in blue there, and you can do that for each of the chemicals, right? Say what their phase is, solid, liquid, gas, dissolved in water. You'll also see in there some numbers in red. These numbers in red are what are called coefficients, and you probably remember that word from math class. And it means exactly the same thing here. In math, if you have three x's, then you might write 3x, and that 3 is called a coefficient, right? Well, if you look at my oxygen in this chemical equation, it's got a 2 in front of it. What that tells you is that there were 2 oxygen molecules, not just one, put 2. And you can see the water there has a 2 in front of it, which tells you there were 2 water molecules produced, right? And just like in math, if you have only one x, you don't write 1x, you just write x, right? Look at my carbon dioxide there. There's no number in front of it, which tells me there was just 1, okay? So you can see the coefficients there. You can see the phase symbols there. And let's talk about what I'm going to ask you to do a little bit. First thing I'm going to ask you to do is I'm going to give you something like a sentence, and I'm going to ask you to write for me a chemical equation, okay? So I have the sentence here. It says 1 molecule of nitrogen gas reacts with 3 molecules of hydrogen gas to form 2 molecules of ammonia gas. And for most of these, I will probably give you the formulas for the chemicals. If I don't, you can, look them up, or you can figure them out. You should be able to figure many of them out at this point. So what I'm going to ask you to do is look at that sentence and write a chemical equation. Okay. So what I'm going to do is I'm just going to start with the reactants. I'm going to read the sentence. Which chemicals are the reactants, right? And usually the chemicals that are the reactants are going to be before the words that tell you about the arrow, okay? So if you find the words react to form, react to produce, to form, to produce, something like that, that tells you where the arrow is. And the chemicals before that are usually the reactants. The chemicals after that, the products. So this tells me 1 molecule of nitrogen gas. So I'm going to put N2 parentheses G, and then I'll put a plus for the other chemical here, which was 3 molecules of hydrogen gas. So I'm going to put 3 H2 parentheses G, and then the sentence says to form. So that's where my arrow goes. Okay. And then after that, in the reactant side of the equation, I've got 2 molecules of ammonia. So I'm going to put 2 NH3 parentheses G because it was a gas, right? Simple enough. So you're going to have a few of those on the assignment, and let us talk real quick about some things that might be frequently missing in these sentences, okay? So I might give you a sentence and ask you to write a chemical equation with it. There might be missing information, okay? I mentioned a second ago, maybe you don't know what the chemical formula is for one of the chemicals. Many of them you should be able to figure out at this point. You have access to the internet. They're very easy to look up on the internet. I will probably give you most of them in the assignment. If I don't, it should be something you really ought to know, like water, right? So if you don't know the formula, figure it out, look it up, right? Second thing you might be missing is the phase that your chemicals are in. You might be missing, the sentence might not tell you if it's a solid, a liquid, a gas, or if it's dissolved in water. If you don't know, it's okay not to put it in the chemical equation, okay? Chemical equations are frequently written without the phase symbols. So if you don't know, just leave it out. If you do know, you ought to put it there, okay? The third thing you might be missing is coefficients. The sentence might not tell you, and probably will not tell you, what the coefficients ought to be, okay? And when you don't know what the coefficients are, you have to figure it out, okay? To figure it out, you do a process called balancing the equation, and that's what we're going to talk about next, is how to balance the equation. So let's get to this fun stuff. Okay, balancing a chemical equation is about figuring out what are the coefficients. You can see here I have a chemical equation that has no coefficients in it, okay? You can see this says that hydrogen gas reacts with oxygen gas to produce water as a liquid. Now, I've left space in front of each chemical where I could write a coefficient, which we're often going to see for a problem is like a blank right there for you to write the coefficient in. And the coefficient might and often will be 1, which means nothing is required to be written in the blank because you don't write a 1 in front of the chemical. But what we're going to do is we're going to walk through and we're going to figure out what are those three coefficients. Now, the big idea here that's going to help us do that is an idea called conservation of matter, right? And conservation of matter says whatever atoms existed when we started our reaction ought to also exist when we finish our reaction, right? So if we look at each different kind of atom, here we've got hydrogen atoms and we have got oxygen atoms. If we look at each different kind of atom, every single one that we started with on the reactant side should also be present on the product side. So let's look at them real quick. Over here, I'm going to ask myself, how many hydrogen atoms do I have on the reactant side of the equation? And here I have 2 hydrogen atoms, and there are no hydrogen atoms in this chemical, right? So on the reactant side, I have 2 hydrogen atoms. How many of them do I have on the product side? Well, here are 2 hydrogen atoms on the product side. So this is promising to begin with. We have 2 hydrogen atoms over here, and we have 2 hydrogen atoms over here. That balances. They're the same. That's awesome. But now let's look at the oxygen atoms, okay? Look on the reactant side before the arrow. I have 2 oxygen atoms on the reactant side. Okay. What about on the product side? On the product side, here's oxygen, but there's no number after it, which means there's only 1. So there are 2 on this side, and there is only 1 on this side. So I have to fix that, because they have to be the same on both sides. Now, if I had twice as many of these, it would work out, right? So you cannot mess with the subscripts. Do not mess with the subscripts. You can mess with the coefficients, and that is all. I'm going to put a 2 in front of that. Now, that doubles the number of water molecules. That makes it 2 water molecules. So in 2 water molecules, each one has an oxygen atom. That means I have now 2 oxygen atoms. And then on this side, I had 2 oxygen atoms. That balances out. But adding that 2 there changed something about the hydrogens, because that not only doubles the number of oxygen atoms, that also doubles the number of hydrogen atoms. So now instead of having 2, now I have 2 times 2. Now I have 4 hydrogen atoms on this side. And how many did I have on this side? I had only 2. However, if I put a 2 in front of that one, now I have 2 times 2 hydrogen atoms on that side. So here we have 4 hydrogen atoms and 4 hydrogen atoms. So now that balances. So now everything here should balance now. Notice we did not end up with a coefficient here. If you prefer, you can write a 1 there. That's fine with me, but it's not needed. Okay? So now before I'm done and I move on, I'm going to look at each different kind of atom and make sure I have the same numbers on both sides. So here, hydrogen, I have 2 times 2, which is 4 hydrogens. And then on the product side, I have 2 times 2, which is 4 hydrogens. That balances. Then for my oxygens, here I have 2 oxygens. And over here on the side, I have 2 oxygens. So everything balances nicely. This process we just did is called balancing the chemical equation. Let's look at another one here. Okay, this one says I have solid aluminum. All right, so the aqueous HCl, this is called hydrochloric acid, to form aqueous aluminum chloride, AlCl3, and hydrogen gas, H2. So let's take a look at this one and let's balance this one, okay? I'm going to start with the first chemical, aluminum. And over here, on the reactant side, I have just 1 aluminum atom, right? There's none in this one, so here's just 1. Over on the product side, I have aluminum right here, and right here, this is just 1 aluminum atom. Don't mistake this 3. This 3 is only on that chlorine, right? So this aluminum is just 1. So I have 1 aluminum and 1 aluminum. That's good. Okay. Let's move on. The next type of atom I see here is hydrogen, the H. Okay. Over here on this side, on the reactant side, I have just that 1. And over here on the product side, there are 2. So I can deal with that, not too tough. I'm gonna put a 2 in front of this one, okay? That makes 2 hydrogens and 2 hydrogens, so that's good. We're gonna run into trouble in a couple of minutes, but you know, we'll deal with it when we get there. So I have 2 hydrogens and I have 2 hydrogens. Okay. Let's move on. Chlorine, I just put a 2 there, right? So now I have 2 chlorines there. And if you look over here on this side, I have 3 chlorines. Well, that's not good, okay? Can I make 2 into 3? I could change this to a 3, couldn't I? Right? But then that's gonna make, here, let's do that. Let's up that to 3. Now I have 3 chlorines and 3 chlorines, and that works out. But what does that do to my hydrogens? Here now I have 3 hydrogens, and over here I have 2 hydrogens. So how do I make them the same, right? What we're gonna do is, you know, it's often easiest to double an odd number and then try to make things work out. So what I'm gonna do is I'm gonna take this odd number of chlorines and double it, and then see if I can make things work out. So now that I've doubled that, let's look at our chlorines. We have 2 times 3. There are 6 chlorines. Can I make 6 chlorines over here? Yes, there's 6 chlorines. Okay. So now I have 6 hydrogens over here. Can I make 6 hydrogens over here? You know, what times 2 will make 6? 3 times 2 will make 6. And that works out. The only other thing I got to look back on is my aluminums, because putting this 2 here messes up my aluminums. That makes there 2. So I need to make 2 over here on this side. So there we go. Okay, one thing that you want to be careful of when you get to the end of balancing your equations. It's always good at the end of your problem to go back and check, right? So I have 2 aluminums, I have 2 aluminums, I have 6 hydrogens, I have 3 times 2, which is 6 hydrogens, I have 6 chlorines, I have 2 times 3, which is 6 chlorines. So everything balances here. But you want to be careful, because if you end up with coefficients they're all divisible by the same thing, then you've gone too far. You always want the smallest coefficients that are going to work. If I had ended up with 4, 12, 4, and 6, I would look at all of those and say that they are all divisible by 2. So I would go through and divide them all by 2, right? Because it would have worked with half as much. So if you go too far and you still end up making it balance, you'll end up with a bunch of numbers that are all divisible by the same number, and you'll want to make that adjustment. Okay, I got one more example here that I want to look at. This one gives us a sentence and asks us to write a balanced chemical equation from it. So if you look at it, it says solid tin oxide, which is SnO4, reacts with hydrogen gas, which is H2, to form solid tin metal, which is Sn, and liquid water, which we all know is H2O. So I'm going to start by writing the chemical equation not balanced, and then we'll balance the equation. So it says solid tin oxide, which is solid tin oxide, reacts with hydrogen gas, to form, that's where my arrow goes, solid tin metal, solid tin, and liquid water. Okay, so there is the chemical equation, but it's not balanced yet. So what we're going to do is we're going to go ahead and balance that chemical equation. So first let me look at the tin, Sn. You can see over here there's just one of them. Don't let the 4 confuse you, that's just on the oxygen. So there's just one tin over here, And on this side, there is also just one tin. So that's good. Okay. Let's move on and look at the oxygen. Here, there are 4. And over here, there is only 1. So let me put a 4 in front of the water. Okay. Let's move on. We have 2 hydrogens here. And over here on this side, we have a lot more than 2 hydrogens. We have 4 times 2. So we have 8 hydrogens on the reactant side. So I need to make this 8. So I ask myself, what times 2 makes 8? And 4 times 2 makes 8, right? So now there are 8 hydrogens, and here are 8 hydrogens. So everything should balance there. So I have 1 tin, 4 oxygens, 4 oxygens, and I have 4 times 2 is 8 hydrogens, and 4 times 2 is 8 hydrogens. If you like, you could put 1s in the blank spots. It's not necessary. You can just leave them blanks. Okay. And then let's just make sure that we don't have everything divisible by the same number. So here I have 1. If you have any 1s, you're not going to have anything divisible. So 1, 4, 1, and 4 are not all divisible by anything. So we don't have to worry about that. So there you are. Okay, so there we talked about chemical equations. We looked at the different parts of chemical equations, and we talked about what the different parts, like the arrow, means. And then we learned how to balance chemical equations. So hopefully that helps us be able to write balanced chemical equations. So until next time, take it easy.